All right, so we're going to talk about one-point perspective. What is one-point perspective? One-point perspective is something that happened during the Renaissance. It was a way for artists to make three-dimensional objects appear real on a two-dimensional plane. So when we think about perspective, we have to realize, that prior to that, artists weren't able to do it. The Renaissance period was this really intense period of growth in Italy, and then it spread throughout Northern Europe. And there was a growth of art, science, and literature during this time. So prior to the Renaissance and to linear perspective, paintings that were made in the Middle Ages were very flat. They looked really odd, actually, and faces were kind of the same. There wasn't like a lot of humanism. Early works showed little depth, and you can look at this picture and see that it doesn't really show depth. It's kind of like there's some depth there, but it kind of looks like just a big wall behind them. And this is part of a altarpiece. So here's a later piece from 1662 by Johann Vermeer, and it's called The Music Lesson. And this is where, even in the North, we start to see artists using very close observation when they painted, and they used linear perspective. So linear perspective allows the artist to trick the eye into seeing depth on what is a very flat surface. And so it gives us a more realistic illusion of what's two-dimensional. So how does it work? Well, it works with this idea of a vanishing point. So the vanishing point are where all these diagonal, or what they're actually called, are orthogonal lines. And those orthogonal lines are meeting to where that center point is. And if we look at the straight lines in the picture, like along the windows and along the tabletop and along the floor, we can see that those lines literally in this painting all move towards that vanishing point. So that vanishing point is really, the idea there is that it's infinity, that it goes off into infinity. So if we looked at this sideways, it would look like an ice cream cone on its side, like a pointed, cone with everything kind of spreading out. And so infinity is like, we can't see infinity. It's too far away. Right now, the wall is in the way of it. So this wall in the painting is like slicing it. But it's the lines work as if you were imagining that you were going through the wall. Like you could be the invisible man and go straight through that wall. So it's based on the way the human eye sees the world. Objects that are closer appear larger, and more distant objects appear smaller. To create the illusion of space, the artist creates a vanishing point on the horizon line. We saw that. And then objects are drawn using orthogonal lines, all of which lead to the vanishing point. So here we have a path with trees next to it. Can you locate the horizon line? Where would the horizon line be?
Would it be like where, like, I want to say like the very back of like the field, or like where the mountains?
Right, where the sky would meet the church, it looks like, and there's like a mountainous area. But also think about, where would you be in this? If you were looking at this, where do you think you would be? The horizon line is very low. So you would be up high, wouldn't you? Maybe up in a building overlooking this road.
Or on a hill leading down.
Yes, exactly. So how did you determine that? Well, you know that the horizon line is where the sky meets the earth, right? So where do you think the vanishing point would then be? Probably right in the center of the path, right where the sky meets the earth. That's where the vanishing point would be. And then where are all the orthogonal lines? Well, they're all the lines of the tops of the trees and the path and so on. So let's take a look. So there's our horizon line. And there's our vanishing point and our orthogonal lines. So this happens over and over and over. Artists use this all the time. They want to show objects face on, right? So most lines are vertical, horizontal, or orthogonal, drawn to a single vanishing point, just like in the very first picture that we looked at, right? Now, the vanishing point in all of these pictures has been right in the center, but it doesn't have to be in the center. You can have a vanishing point off to one side, like we do in this little colonnade. And here we have a door in the way, right? So it's like there, back behind that door. So where do you think the vanishing point would be? Probably where the railing is. Like the floor is not always the vanishing point, right? So see how straight the railing is? Same here. So I'm going to just kind of go through some of these. All right, so the horizon line is horizontal. It goes from left to right and is parallel to the bottom of the picture. It represents the viewer's eye level, just like what we talked about a minute ago. It is the place where the ground and the sky seem to meet. You can see the top of an object if it is below eye level over the horizon line. If the object is above eye level, above the horizon line, you cannot see its top. Now this is really interesting because there was actually a study done with students who were learning how to draw. And so they were college students, and they took a box, right, like a shoe box, and they said, okay, everybody, here's what we're going to draw. We're going to draw this shoe box. And then they put it on the top of a cabinet where the students could not possibly see the top of the box, but they drew it anyways. So this tells us that people don't really look, that they draw from memory or try to, right? But people most of the time don't have photographic memories. And so, there's that where then they're drawing what we call a schema or a schematic, like what they remember, whatever that might be. So, okay, so let's get started. Let's draw a horizon line, and I'm just going to kind of go through this really quickly. Across your paper, put the vanishing point on the horizon line. Now, this is exactly how you're going to make your thumbnails, except a little different. So, but I want you to kind of see how it would start. And then from there, we would create a shape. And then from that shape, we would start to make orthogonals going towards the vanishing point. Okay? And so now we can go ahead and put another. So you'll notice that the horizontal lines are all parallel to each other, and the vertical lines are all parallel to each other. The only ones that aren't parallel are the orthogonals, right? So you can see the top of that cube. If we go here, the top of the cube has two horizontal lines that are, and then one at the bottom. And then if we look at the side, there's three lines that are orthogonal. And then if we go to the vertical lines, you'll see there's three that are all exactly vertical and exactly at the same angle as the thing. So let's go back. That's how you started it, and then that's how you finished it. You erased out those other lines. And then here we have some more things happening. So there you can see how you could create a window, and more buildings, and more buildings, and you can stack forms, and so on, right? So this is the basis of perspective drawing. And there we see all of that. Now, I'm not going to make you do a perspective drawing for this class. What I want you to do, though, is think about how overlapping deep space images using the aid of linear perspective can give you the sense of movement. That's our goal. So it's a little different than what we see happening in these, but that's all right. I just wanted to go through them. So let's take a look at our project. So this is going to be our dynamic line project. from weeks 3 through 7. So the problem is going to be, first of all, to develop 2 now non-objective designs. So what is non-objective? What do you think non-objective could mean? Anyone?
They don't need to be something, like they don't need to be like a city or something.
Yeah, that's a good start. Well, they don't need to be something you can recognize. So like if I put a stop sign as a shape, what would you see? You would see a stop sign. Even if it didn't say stop on it, you would still see a stop sign, right? If I put a star as a shape, you would still see a star. But if I put a circle, it's just a circle. A cube would just be a cube. Does that make sense to everyone? So it's non-objective. There's not something that I automatically reference it with. A star wouldn't work because I automatically reference it with a star. A stop sign shape wouldn't work because I automatically reference it to a stop sign. So you don't want it to look like something, if that makes any sense. It needs to be non-objective. So not look like something else. That's the first, most important part. And then you're going to use line. I'm sorry?
So basically you need shape.
Simple shapes, exactly. And I'm going to show you a bunch of examples. And then you will be using line, shape, and texture, but you're not going to be using your pencils. You're going to be using your micron pens. So we're going to learn how to make texture by using line networks. And that's also in your content management system. There's a lot in there, but we'll talk about that as well when I show you the examples. So in this problem, we will develop larger, more ambitious designs and explore ways to create the illusion of space. So you see how we're taking a bunch of those elements and principles and we're pulling them together for our first problem. And we're going to try to understand how, if I move things around, how it's going to change the way it looks. Okay? And this is non-objective because I don't want you to have to worry about drawing. I don't want you to worry about making it like a perfect thing. All right, so what are you going to use? The materials you'll use for this course, with this problem, will be the micron pens that were in your kit, Sharpies, and your sketchbook. That's your rough drafts. And then when we get to our final, we're going to do it on the watercolor paper. So the first thing you will do is use thumbnail sketches, roughly 3 by 4 inches, to rough draft at least 12 ideas. No 2 ideas should look alike. Have your thumbnails ready and you'll hand them in on the content management system. There's a drop box. Thumbnails should not be shaded. They should only be lines and look like a coloring book, ready to be shaded in. So do not shade the thumbnails. Do not shade the thumbnails. Very important. So you need to just make it with line, with your pencil. That's it. And they don't have to be perfect. Once 2 of your thumbnails have been approved for a full design, you will begin your work on your 8 by 10 rough drafts. Oh boy, here we go. See, I can't. Okay, that's it. See the rubrics for each section. Pay special attention to the edge of the composition. When a line or shape intersects this edge, the composition generally appears to expand beyond the page. So what that means is you're going to have stuff go beyond the page into the viewer's world. So like when you look at a window and you look out the window, you see part of the tree. You don't see the whole tree, right? Because the wall is blocking it. But because it's there, you believe it's there. You know it's there, even though you don't see it all. Overlap variations in size, location, and degrees of definition can be used to increase the illusion of space. So overlap is when you have one thing that goes on top of another, and it allows for it to feel like it's in front and it's in back, even though it's two-dimensional. Experiment with both symmetrical and asymmetrical balance, and symmetrical balance is often used. So we've talked about that in our last discussions about symmetry and non-symmetry. And now we're going to look at some examples. So this is a pretty complicated one. It's pretty cool though. Like if you think about where the vanishing point is, the vanishing point is in the upper left. And what they did was created these kinds of circles and planes. So see how those planes almost feel like they're going like flying into that vanishing point? So that really worked well. But that's pretty complicated. And I don't expect everyone to kind of go to that depth. But I will show you some others that I think are very cool. So here's another one. They used a vanishing point, and in this case, they used some orthogonal lines, and then they used some other shapes that they created on an orthogonal line and sort of made them bigger and smaller. So see all the spheres that are kind of floating and moving in? And then there's sort of like that, it almost looks like a, you know, like a lightning bolt and some other shapes that are kind of moving in. Very cool. Here's another one. So here we have their orthogonal lines kind of going out to both sides. Notice that there's not any shading. The only way that they're shading is by using their micron pens. So they're actually creating a kind of circular line network that makes it feel like they're going from light to dark. So remember, not white to black, but light to dark. So the lines that are in the kind of ribbony area are really feeling like they're getting smaller. And notice all the little cubes way back in the center, because the lines are closer together. When they get, and they're darker, the farther away they get. Here's another one. Interesting. I really like this one a lot. I think this one really kind of, you know, helps like have fun with sort of an Escher-esque, like you're kind of looking through these black, you know, circles that have depth to them, and then there's stuff happening behind it. So this one got really creative. Here's another one, and this one used a lot of the orthogonals, but then came back and did like circular kind of ribbon-like lines moving all around. Here's another. Again, notice the way that they worked with texture. Here's one that's actually hanging on the wall. A student did this summer. Really interesting. And then here's one more. So with that, I'm going to stop the video and definitely go into the Blackboard system so that you can look at the rest of the material. So, hit escape.